Sir, yesterday we discussed few set of problems where a particle hits a rod at some point, right, sir?
Yeah.
Sir, there the rod has both translational and rotational motion after the particle hits it.
Yeah, fine. Yeah.
So we can use this formula, right, sir? I mean, if we want to find angular momentum about some point other than the center of mass, then we can use angular momentum about that point equals angular momentum about the center of mass plus mvr.
Oh, my dear, look at. If you take any other point, what is the problem? That particular point will also have what? Linear velocity, no?
Yes, sir. That is what is accounting for this mvr, right, sir?
Then what happens? You are defining angular momentum about a point which is moving. Then you can't write L equal to I omega.
No, sir. We will not be writing L equals I omega, sir. Just we want to find angular momentum about that point. We will not express it in terms of I omega, sir.
We have discussed this concept, no? Because say when rigid body rotates about an axis, about that axis is what L equal to I omega. And from
Yes, sir. Yes, sir. I don't want to define it as I omega, sir. I want to define it as something else,
some
sir.
other thing, okay, fine. If you are able to conclude mathematically, fine. But you can't conclude.
Okay, sir. But if we think the rod, the particle hits the rod at some point. Let's say it hits the rod at one end, sir.
Mm-hmm.
Then about that point, there is no impulse. I mean, there is no angular impulse on the rod about that point.
Okay, yeah.
Then we can what do we say? We can conserve the angular momentum of the rod, not the whole system, sir. Of the rod about that point.
Of the rod only you're telling.
Yes, sir. Only of the rod because
Only.
there's no angular impulse.
Okay, then write it equation C. What you'll get?
So if we say that the rod is not rotating initially, then we get there's no omega about that axis for the rod, about that end.
I'll explain here. This is what you are saying, no? The particle will come in, collide. This will come and collide. So there will be an impulse will act. Now this impulse will act like this here. It will act like this here. Now tell me, you want to consider angular momentum about this point?
Yes, sir. Only of the rod, not of the system.
Background, somebody is talking.
Oh, 1 second, sir.
Yeah. No. If you are applying about point A, let's say that.
Yes, sir. There is no angular impulse about point A.
Now, for the rod you want to apply?
Yes, sir. Only for the rod.
Only rod. Then initially for the rod, what happened? It was a test, and we know afterwards it will rotate, no?
Yes, sir. It will rotate about center of mass, sir. But it has no omega about that end, sir. There is no omega about that end.
Then you see what is it then? So impulse is acting.
So yes, sir. So it will have angular momentum, like the whole rod has a translational velocity of v towards right, sir.
That'll be V2.
So
That
there
one.
will be angular momentum for that, sir, not due to omega, not due to rotation.
There's only translative motion you're telling, and there's a, since about this point there's no angular impulse is acting, so therefore it's only translative motion. But practically, what's happening?
Yes, sir. Yes, sir. That's what my doubt, sir. Practically, it is rotating, but I'm not getting any angular momentum about that point, sir. That is the problem.
Yeah, so rod will see rod rotates or not rod rotates. So then what you should define in such a way
Yes, sir.
that
Definitely
where
rotates.
see the equations what you're writing should define the physical conditions, and you're writing the equations where not defining physical conditions. Some problem is there with your application part.
Yes, sir. I don't know what the problem is, sir. That is
So
what I'm asking.
if you take first, you have to mute your television there.
So it's not television, sir. 1 second, sir.
No, this is the axis. Huh? About this axis, you want to apply the angular momentum of what? Of for only rod. Conservation
Yes,
of
sir.
angular momentum of only rod. Okay, fine.
Yes.
The rod is there, this one. Then what happened? What is the biggest problem is the rod, in fact, about this particular point, it's not rotating. It's rotating about some other point. It's rotating about some other point. Then, so the angular impulse equation, what it says that as it is axis of rotation is intersecting, so there's no angular impulse, so the rod should not rotate. But practically it's rotating, no? So something the physical condition itself, you are saying that it's wrong. So definitely all this will become meaningless.
No, sir, but the application part, like there's no wrong, nothing wrong in the application part, so but I'm
My
getting the
dear,
wrong
like
result.
you're telling that what I'm seeing is wrong. If I apply force and you say that body will not move, but in fact body is accelerates,
No, sir,
then
that's not what I'm saying, sir. The body will not rotate about that end, but it has angular momentum about that end. That is due to the velocity, translational velocity,
so
mvr, not I omega.
here if you see the velocity of this will be v2 minus r omega. Different points, they're having different linear velocities here. Different points, and this particular point which is accelerating is also having some velocity, and the axis itself is not fixed here, will be moving, it's also having velocity. Then if you try to define that angular momentum, the different particles, they're having different you assume one strip here, one strip here, one strip here, one strip here. So then what happens, the different points, they're rotating here. You calculate that, you calculate that. Because again you see this particular particles, they'll have velocity like this particular particle, they'll have velocity, and maybe this particular particle, they'll have velocity. So when you add up all this particular strip like this, due to this, I think I'll bring it here.
No, sir,
And
that is in the center of mass frames. I mean, you are doing that
you
in
you
the
you
axis of center of mass.
you
What I
you,
want about that end, sir.
you allow your teacher to talk first, huh?
Sorry, sir.
So this is angular momentum. So the net velocity of this particle may be like this. The net velocity of this particle will be like this, huh? Then if you calculate the angular momentum, this one, definite open will come 0.
Yes, sir. Yes.
Will come 0 here. And what is use of this? No use.
Yes, sir. Exactly. Uh, if we consider the axis to be our center of mass, passing through the center of mass, then there's only I omega term. There's no mvr
Anyway,
terms.
so
All of them are getting cancelled.
when you are finding out this, what when you should know mass and the distance. Calculate angular momentum of this will be like this. The angular momentum of this particle will be anticlonal. Like this, if you add up all, it will become 0. Fine, justified, no?
Yes, sir. Yes, sir. There's no mvr, but there is I omega if we consider the axis to pass through the center of mass.
Center of mass. That is the reason, yeah. So finally, what all you do this
Yes,
bigger
sir.
mathematics, it may
So
take 1 hour and it's of
exactly
no
like
use.
that, if we do it for that end,
Yeah, you'll get it. See, due to what happened, you calculate the velocity, total velocity of this part, not v2. It will be v2 plus r omega 2, r2 omega 2. So call this sum. v2 plus, so it will be r2 omega. What about this one? This will be like a v1 or say va, vb, we'll call it. I think I made some vp, I'll call it vq. What is vq equal to? r2 plus omega 2. What is vp is equal to? Vp will be equal to some distance you calculate, and the velocity of that will be somewhere like this. Then calculate angular momentum of this and this, like this you integrate. No, the total will be 0 about point A. Finish. Sure. What is use of this? No use. That's why we are not bothered about that.
no, no, sir, that's wrong, sir. I mean, we are telling that no, sir, that's not correct, sir. I mean, for point P, you're saying velocity minus some omega r, but that we are calculating. I mean, our axis is passing through the center of mass there, but here our axis passing through one end, sir. Will not consider that anymore.
This omega will not be there about A, it will be there about O only. Your mathematics will end up like this. That's all finished, ma. I think you can't change omega. It will rotate about
Yes,
A
sir.
means something wrong. So it is simple idea. If you
No,
calculate the
sir, it
angular
will not
momentum,
rotate about A, sir.
it will rotate about O
Sir,
only.
it will
So
not
then,
rotate about. Yes, sir, it will rotate about O. It will not rotate about A. That doesn't mean it does not have any angular momentum.
so it will be there. No, it will. If you calculate mathematically, it will end up 0. That's why it's of no use. That's why the books didn't bother. Without you should work out mathematically. It's very
Sir,
difficult. Yeah,
no,
that
sir,
much.
I did it, sir, but no, sir, I worked it out, sir. I'm not getting the exact result.
Will be zero. Will be zero, no doubt. If you calculate angular momentum about
No,
point
sir.
A, you
If we
should take
consider
about
only the second